If you have any question from about the course or about the last session, please ask me. Any question? Okay. In the last section, we talked about networks, and we received to the topic access networks. We say that we can use cable modem access networks, cable access networks, or different types of DSL technology and something like that. Also, we can use access network in home. To do this, we need a modem connected to a cable, phone cable, or a fiber or something like that, and we can create a network inside the house. For example, a wireless network or a wired network. But we know that a home network is a small area. Here you can see that. Here you can see a circle with dashed line here around the access point, a router, and a modem. Because in a home network, these three devices are grouped and built in one device. When you buy an ADSL modem, that modem has a wireless antenna, some wired output, and a DSL modem. Amer says he cannot hear my voice. Amer said, please leave the class and enter again. Amer said, please leave the class and enter again. Sound is cutting. I think the problem is with the server side or internet, because my link is good. Quality of my link is very good. It's complete. Okay. What about the other students? Are you hear my voice? Do you hear my voice correctly? Is it okay? Okay. Okay. Another access network is wireless access network. When we talked about wireless access network, we talked about a shared medium for sending and receiving data. This shared medium, we call it shared because I can use that medium, and at the same time you can use it too. So it's a shared medium. A third person can use too. So this medium, most of times air. But for example, we have some wireless network underwater in the sea, submarines and ships, something like that. Okay, but mostly we talked about when we talked about wireless network, we mean that the air is the medium. Okay, so on this air, we are talking about air. Okay, on this air, I can send information. You can send, another person can send too. So the platform, the medium is shared, and on this shared medium, different people, different systems can connect together. But when we tried, sound is cutting. I don't know what should I say. When we talked about accessing to internet via a wireless network, we need special tools, special equipment. We called it base station. Base station is an antenna. I'm connecting to the antenna using a wireless medium, and that antenna is connected to the internet using wire. So base station is a medium, is an equipment to connect me to internet. In wireless in wireless LANs or Wi-Fi, this base station is called as access point. In cellular networks, we called it as BTS. Okay, in different platforms, this name may change to another one. For example, in WiMAX, we called it as base station. Okay, so when we talked about a base station, we means an antenna. We connect to it to connect to internet. Okay, two common types of wireless network access are one of them is wireless LAN and the other one is cellular access network. In wireless LAN or WLAN or Wi-Fi or IEEE 802.11, Wi-Fi IEEE 802.11, wireless LAN, wireless local area network, all of these names are same. Okay, WLAN has a communication range of 100 feet, something between something near to 30 meters, 30, 40 in an outdoor, maybe until 100 meters. and its transmission rate is a number between 11 megabit per second to 550 megabit per second, and in new series, in series AC or AD, its speed is more than 1 gigabit per second. Wi-Fi has several versions: version A, B, G, N, I, E, AC, AD, and some other versions. Each of those versions has a specific properties, and the newest versions are AC and AD. The speed or transmission range in AC and AD is more than 1 gigabit per second. Okay. For wide area wireless access network, we can talk about cellular access network. In cellular access network or mobile cell phones network, we have a network with minimum communication range of 500 meters. Its maximum communication range is a number between 30 kilometer to 45 kilometer or something like that. So hundreds of kilometers. Its maximum range is hundreds of kilometers. Microcell and macrocell. In microcell, communication range is 500 meters or something like that, and in macrocell, communication range is 30 kilometers or something like that. Okay. The cellular wireless networks has different types, different generations. Currently, we are using fourth generation of cellular network, third and fourth generation, 3G and 4G wireless cellular network. But during the next years, the 5G will be available in most of countries. However, I'm not optimist about the 5G because it has several health problems, environmental problems. Why? Because in 5G we are using in 5G we have this problem, and we can see only Chinese are developing 5G platforms. So I think we should be care about this technology and about with these frequencies. These frequencies are very dangerous, very dangerous. We should be care about them. But in 5G environment, there are several interesting capabilities. For example, in 5G, for the first time, artificial intelligence algorithm has been used to manage the network, manage users, and different aspects of network. Okay. Another access network is enterprise network. When we talk about enterprise is a big company, is a big organization, such as a university. Okay. In an enterprise, we have several types of LANs, local areas, several types of networks, a mixture of wired and wireless networking technologies, different types of switches, and something like that. But today's mostly for when we talked about wired LAN, wired local area networks, the Ethernet technology, the Ethernet standard is common. Okay, it's dominant. The Ethernet technology has a speed of 100 megabit per second, but its today's speed is 1 gigabit and 10 gigabit per second in a LAN. Anna Kazim asked me how many bandwidth in 5G. It depends. Hannah, it depends. But we know that in 5G networks, we cannot use bandwidths or frequencies with low rate of frequency. You know, for example, in the second generation, we use frequency near to 850 megahertz. Okay. In the third and fourth generation, we use frequency near to 1.8 gigahertz, and now in 5th generation, maybe 1.8 gigahertz and maybe over 60 gigahertz. We use one of these frequency bands, but over 60 gigahertz, it's very dangerous. Hassan Abbas, I answered to your question. It's dangerous. Why? Because of its frequency range. When we are using frequency ranges over 60 gigahertz, it has side effects, which is not good for health. Yes, if we use high frequency, it's not good for our health. Even frequency in this fourth generation or third generation, 1.8 gigahertz. If you stand in the range of those signals for a long time, your body will be affected, and maybe different types of cancers, for example, blood cancer, is completely possible. It depends. I cannot say 4G is better. If both of them use same frequency ranges, for example 1.8 gigahertz, their problems are similar. But when we talked about higher frequency, it's not good at all. Okay. In access networks, in an enterprise, for wired access network, mostly we use Ethernet technology, and for wireless access network, we use Wi-Fi technology or wireless LAN technology. We talked about them in the past. The last access network is data center networks. In data center networks, we have several hundreds or thousands of servers placing in a small area. Those servers are connected through very high bandwidth links. The minimum speed in a data center is 10 gigabit per second, minimum speed, but mostly 40 gigabit per second or even 100 gigabit per second connections are used in data centers. And data centers are directly connected to backbone networks and to very high bandwidth links in the internet. In an access network, you are connecting to low bandwidth or to medium bandwidth links, but in data centers are connected to very high bandwidth links. Directly, they are connected to backbone of internets. Okay. The second topic is that in computer networks, when a host sends information, a message is created by application layer. This message should be sent over the network, okay? But the network, before transmission, in the host, the message would be breaks into small chunks. We call them packet. Packet is a small chunk of a message. Okay. Our packet has a length of L bit. So in the network, we are trying to send an L bit packet over a network with transmission rate of R bit per second. So simply, we can say, okay, a packet with L bit per second would be transmitted in the time of L divided by R second. We call this as transmission delay, packet transmission delay. The time that a packet is transmitted over the network. L divided by R. L is length of packet and R is transmission rate of network. Please be clear. When we talk about transmission rate, it means capacity of the link, capacity of network. However, it's different from bandwidth. Bandwidth is something else. Although bandwidth and transmission rate has direct relation. Okay, both of them have direct relation. Higher bandwidth means higher transmission rate. Lower transmission rate, lower bandwidth. They are directly connected together, but they are not the same. Be care about it. Transmission rate is not bandwidth. Bandwidth means that the frequency range, the difference between the higher and lower frequency in a band dedicated to our application. Each application has a frequency range. Okay, what is the difference between the lower frequency and higher frequency of that band? This is bandwidth. The bandwidth is presented in hertz, but the transmission rate is presented in bit per second. So they are not the same. Okay. The next topic is that, okay, we talked about access network and network edge, but how we connect network edges to access network? The answer is media, physical media, using physical media. This physical media transmits data in the form of signal, transmit data from one system to another one. The physical media are divided into two categories. The first one is guided media, the other one is unguided media. The guided media, in a guided media, signals are transmitted over a cable. If you want access to the media, you must access to the cable. Cable like copper, like fiber, like coaxial fiber, coaxial cables. But in unguided media, such as wireless networks, we are propagating our signal over a wireless platform, over a shared platform. So if someone stands in our communication range, he or she can hear our signals. It's obvious. Just stay in the communication range in unguided media. You will hear the voice. Okay, let me talk about different types of physical media. The first one is twisted pair. It's a cable that we can use it in our traditional telephones. There are four couples of pairs twisted together, okay, with different colors. And there are twisted pair cables have several categories. Today, when we are using standard Ethernet for LANs, we are using category 5 of twisted pair cables. And when we are talking about 10 gigabit per second Ethernet, we have to use category 6. You can, if you look around yourself, you can see that in most of places we are using twisted pair cables. The next physical media is coaxial cable. You can see this cable in TV. You are connecting your antenna to your TV using a coaxial cable. Okay, the shape of coaxial is here. There is a copper core in the center, then a plastic coat, then a mesh in a copper mesh, and finally a plastic jacket. This cable is bidirectional and broadband. Bidirectional means that you can send and receive signals at the same time under this coaxial. This cable, and broadband means that the supported frequency ranges or channels by this cable are too many. It supports very high frequency channels, too many channels. Okay. The third media is optical fiber. In optical fiber is created from silice. You can see silice in the glass on windows. So they are from a single family for optical fiber and glass, Windows glass, glass of Windows. Okay. Here, over the fibers, each fiber carries laser lights, laser signals. In optical fibers, we can see the speed is very high, the transmission is very high, the transmission range is something between 10 gigabits to 100 gigabit per second, and maybe more than this. And in a fiber optic, cables have low error rate. Low error rate means that maybe a few bits are corrupted during the transmission. Why? Because in fiber optic we are sending data in the form of light, not in the form of electromagnetic signals. So there is no noise for them in the environments. Okay, so their error rate is very low, and they are immune from electromagnetic noise, and we only need to repeat those data in very long distances. For example, each 100 kilometers, we need a repeater or a amplifier to send gain data to another place, to far distances. Okay. As unguided media, we should talk about wireless radio. When we are talking about wireless radio, we talked about electromagnetic signals. So electromagnetic fields can affect on them. These signals are propagated through the air or somewhere else, but not through the wire. They are broadcast, propagated around an area. And wireless radios are half duplex. It means that only they can send or receive, but not at the same time. They cannot send and receive. They should send or receive. Okay? Why? Because they are using a single spectrum, a single frequency for sending or receiving. So we cannot send and at the same time receive data. It's very important. So we call them half duplex. It means that we should send or receive, but not both of them. When we talk about wireless radio, we should be clear about the propagation environment effects. The environment around a wireless radio affects on the signals, on its signals. These effects are reflection, obstruction, and interference. Reflection means that an object can reflect a signal, something like a mirror. Something like a mirror. A light reflected by a mirror toward another direction. For example, maybe some of you test this in mountains, having this experience in mountains. How, for example, in mountain, in some places you see that your cell phone has no signal, has no received signal. Okay, but when you change your position, you can see in some spaces, in some points, it receives this. Your phone receives the signal. But why? How does it possible? It's easy. At that specific point, your phone receives the reflected signals. The reflected signals. So at that point, you can see, okay, my phone has signals. But when you change your position, you have no signal. Okay, this is reflection. The second one is obstruction. What does it mean? The objects surrounded the wireless network observe energy of signals. How? For example, when you are going into an elevator, or you are traveling across a tunnel. Okay, you are traveling across the tunnel. If you look on your cell phone, you can see, oh, there is no signal. Why? Because the signals are observed. The energy of signals are observed by the tunnel, or are observed by the elevator, structure of elevator. So you can see your signal is weak, or maybe you have no signal. Please pay attention. A receiver can only receive the signals with a minimum threshold of energy. Each receiver has its own minimum threshold. Signals with energy lower than that threshold cannot be detected by that receiver. For example, you can see some trained dogs are brings to, for example, an area and to an earthquake. After earthquake, you can see some dogs in SOS teams. But why? Why they are using dogs? Because a dog can hear weaker sounds. Its receiver, its ear, is stronger than a human ear. So the dog can hear weaker sounds than us. Okay. The third effect is interference. Interference means that I can send a signal and the other one can send too. So because both of them have similar frequency, they can affect together and destroy shapes of together, shape of each other. For example, if I'm talking and another one tries to talk at the same time, the third person can hear nothing. Why? Because he receives two signals at the same time, a mixture of two signals. So maybe his ear is very good. If he could detect one of those signals, his ear is very good. Otherwise, he can hear nothing. He can understand nothing. He is here. He hears, okay? But he cannot detect those voices. Why? Because the received signals are destroyed because of interference. Those signals destroy each other. Okay. Let me talk about radio link types. We have several radio link types. For example, Wi-Fi. We talked about Wi-Fi. We talked about fourth generation and cellular networks. Okay. Bluetooth is another option, another case. Bluetooth, the range of Bluetooth is very limited, just a few meters, short distances. And also the rate of a Bluetooth networks is very low. Another type is terrestrial microwave and satellite. These two types are similar together, but terrestrial microwave is mounted on the Earth, but satellite is placed in the sky. Okay, this is the difference between them. Terrestrial microwave are mounted on the Earth, and satellite microwaves are mounted on the Earth. In both of them, we have 45 megabit per second channels, but there is one main differences between terrestrial microwave and satellite, because here we are using microwave in both of them. We are using microwave, so those signals are very sensitive. They cannot tolerate even simple annoying objects. An object right places in their propagation path. They cannot tolerate them at all. Even a tree, even a wall, everything, even a clothes can affect them. Okay? So their path from the sender to the receiver should be completely clear, without anything. So you can see TV antenna, big TV antennas mounted on top of tall buildings or something like that. Why? Because they are trying to avoid annoying objects, avoid obstacles, environmental obstacles during the pass. For a satellite, the satellite is in the range of a few hundred kilometers to 30. We have a line delay, but how much? How much is delay? Let's suppose that the signals are transmitted with a speed of V meters per second, and this distance is d meter. So the delay is V divided by D. The propagation delay from the Earth to the satellite, or from the source to destination, is V divided by D. V is the speed of transmission and D is the distance. So, what is V? V for wireless network is 300,000 kilometers per second, or 3 times in 10 in power of 8 meters per second. The light speed, okay? In wireless network, the speed of signals is equal to the light speed. Okay, but in cables, the speed is a little lower than this. It's 2 times in 10 in power of 8 meters per second. In wireless environment, the speed is the speed of light, but in cables, the speed is something lower than this. Okay, this speed is related to physical specification of the medium. Please be clear. This speed is completely related to the physical specification of the medium. Maybe you find a medium with a speed lower than these numbers, or maybe higher than this. But the maximum speed is speed of light. The maximum speed. Okay, simply put these values into the equation and find the delays for a satellite, for a TV satellite with 36,000 kilometers above the Earth's surface. We need something about 135 milliseconds to send data from the Earth to the satellite, and something near to 135 milliseconds from the satellite to the Earth. Totally, the total delay is a number between 250 to 270 millisecond end-to-end delay from the Earth to satellite and again to Earth. The end-to-end delay is a number between 250 to 270 milliseconds. Okay. The network core. As we talked in the last network core, we talked about very big bridges connecting sources to destinations. Okay, a mesh of interconnected higher speed. Those links have very high bandwidth. In today's network, mostly we are using packet switching technology to send data across the network. But what is packet switching? In packet switching, when we try to send data, firstly, we divide messages. So the network role is that sending those packets one by one, sending those packets from the source to destination. The network should find the path from the source to the destination and then forwarding those packets toward the destination. Okay, this is the network core. This is the network core. To do this, the network core has two functionality. The first one is routing. In routing, we have to find a good path between the source and destination. A good path between the source and destination. But what is good path? I don't know. It depends on our definition. Look at this picture. For example, I'm trying to move from St. George to from the east of the USA, from a city in the east of in the west of the USA toward a city in the east of the USA. Firstly, I should find a route between that points, between those cities. This is routing. But which route is good? There are several routes between them. You can see here, there is a route in red and another route in black. Okay. Great. Okay. There are several routes, but which of them is better? I don't know. Maybe in this picture you can see that the red route is you can drive in the red road 450 hours, and the gray road needs 45 and 48 hours. Okay, so the red one, it seems the red one is shorter than the gray route. Okay, this is routing. So in networks, we need a routing algorithm to find the best or shortest path. But we have to define what is shortest path. Okay? Firstly, we find the shortest path, and then we store our information about the roads in a special table. We called it forwarding table or routing table. There is this big differences. There is a small differences between forwarding table and routing table. Forwarding table is a subset of a routing table. These differences is this. Forwarding routing is a subset of routing table, but we here in this course we are not care about these differences. Okay, we are not care about them. You can use forwarding table or routing table instead of each other. Okay, so we apply a routing algorithm to create or to complete our forwarding table or routing table. Okay, then when a packet arrives to the router, we should check this one. Okay, destination address. It's a destination address. I'm looking on this table and the third row. For destination address 0111, the output link is 2. It means that this packet should be forwarded through the outgoing link 2. So a router firstly should find a route, complete its routing table or forwarding table, and then for each packet, please attention, for each packet, one by one, we should repeat this strategy for each packet. One by one, we look for their destination address, and we find the output path for that packet. Then the next packet. Again, we should for destination and find the output link for the next one. And we repeat this strategy, this function, multiple times in a second, one by one for each packet. So firstly, we should find a route, and then we should forward through that route toward the destination. Okay. One main principle in packet switching is store and forward. What does it mean? It means that in packet switching network, we have to send one packet from one system to the next system in the path. Find the path and send a packet from one system to the next one system in the path. And then store the packet completely in that system. After that, send the packet from that system to the next one. Store a packet in the next one and repeat this strategy until the end of path. So store and forward means that at each hop, we should receive a packet completely and then send it to the next hop. This is a store and forward. And we know that transmission delay is L divided by R second from sending one data to send a packet from one hop to another one. Naima, I will finish it in a few minutes. Please pay attention. I will finish it very soon. Okay, this is for a store and forward. For example, if I have a packet with length of 10 kilobit per second and a network with transmission rate of 100 megabit per second, the transmission delay, one hop transmission delay is 1/10 of millisecond. This is the effect of store and forward, but here you should be clear about pipeline strategy. Here we can use pipeline strategy. How? When I'm sending a packet from one hub to another, from one system to another, at the same time I can send one packet from this router to the next hub. It means that I can send multiple packets simultaneously at the same time between different hubs. Sending, for example, a packet from hub A to B, and at the same time I can send a packet from B to C. This is pipeline, and please read about pipeline in the internet. Search for pipeline and read about it. What is pipeline and how it affects on network capabilities. It's very important and interesting. Another one is another principle in packet switching is queuing. In packet switching, each system can send information whenever they have enough information. Whenever they create a packet, they can send it. there is no dedicated bandwidth. The bandwidth is shared. So they can send packets as soon as they have enough information. So maybe we receive more information than our capacity. For example, here we have a link. We have a 1.5 megabit link, megabit per second link. Okay, but the data transmitted by A and B are higher than this capacity. So we have to put extra data in a queue to clear this delay. This delay should be empty before I could send another packet. The link should be empty. So we need queue. We have a queue globally. We have a queue when the arrival rate be higher than the service rate. Always, if the arrival rate be higher than the service rate, we have a queue. That is obvious. Okay? But what is the effect of queuing? The queue grows in size. After a while, the queue will be full. And after that, the queue cannot accept new packets. It's very important. The queue cannot accept the when the queue becomes full, the rest of new arrival packets would be dropped. They would be lost. We lost some packets because the queue is full. So we have to use some specific techniques, some special techniques to manage the queues. Because when a packet drops, or when a packet lost, we lost some information. We lost we waste our energy. For example, let's suppose that I'm staying at home, okay, and I'm trying to download some data from a server inside the USA, for example, okay. Those packets are traveling from the USA toward my city, my home, but at the last hop, for example, the packet enters into a queue and drops. So I waste everything. That packet uses several resources during its path toward my city, toward my home. But at the last step, it has been dropped. All resources has been wasted. So it's not good. We have to use queuing management techniques for this case. Okay, this is the last slide. The alternative of packet switching is circuit switching. In packet switching, I am sending packets one by one. Each packet is routed and forwarded one by one toward the destination. Okay, but in circuit switching, firstly, we have to set up a circuit, a tunnel between the source and destination. we have to set up it. We call setup step. To set up the path, the circuit, this circuit is dedicated. It means that it remains for myself. I can use it or don't use it. It's not important. I should pay for that circuit, even if I use it or use not. Okay, I should pay for that. This circuit is dedicated to me, and nobody can use it. Nobody can use it. Just I can use. Okay. There is no sharing here. No sharing resource. Okay. Circuit switching is common in traditional traditional telephone networks. When you hang up the phone and dial a number, after a while you can see beep, something like this. This beep means that okay, the circuit is set up. Wait until the next side hang up answer the phone. Okay, but if you hear beep 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 something like this, this means that the circuit, we cannot complete the circuit. We couldn't complete the circuit. Why? Because of, I don't know. During the past, we couldn't guarantee, we couldn't reserve enough bandwidth, enough resources. Because I said that the bandwidth are reserved dedicatedly, mandatory. We cannot assign a resource to more than one person. It's dedicated. So when you hear beep 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 something like that, it means that I cannot reserve resource for you. There is not enough resource for you for reservation. Okay. This is another type of switching. So we have a packet switching vs circuit switching. Next week, inshallah, I will talk more about these types of switching. Is there any? Read the source book. I prepare a link, download link for you to download the book, the 8th version of book. I prepare it for you. Please read the book. After that, you can read the slides too. Okay. Is there any question? Okay. I wish the best for you in the rest of this week. Have a good day.